So multiple choice number one. For this question, you can start off by looking at the asymptote. So you can see we have an asymptote at, make this a bit thicker, x equals 5. So you can start with that, and you can see the only option we can really get rid of is C. And the other one we can look at is Y asymptote. That one's Y equals 6. But we can't really get rid of any asymptotes with that one. So we're left with A, B, and D. And the other thing we can look at is the overall shape. So a positive hyperbola would go like this. So this one has to be negative. So we can look at the answer options and we can get rid of E. The other ones all have a negative in them, and B is like the denominator is 5 minus x. So that can be written as minus x minus 5. So that one's also a negative. And the last thing we can look at to differentiate between A, B, and D is the point. So for that one, you can just put 35 on 6 into your cas and see which one gives you 0, and that would be B. So for this question, we have a point and it lies on the graph of this one. So the easiest way to do this one is just to graph this, put that into your cas and check what the curve looks like. I'm pretty sure it looked something like this, and this was half, -3. So you know that's that's a stationary point. So it's when ddx is equal to 0. So then that's when the gradient is 0. So this question is a bit, it's not tricky, but it's kind of, the answers are shown in a hard way. So the first thing you do is just put this into your cas, and you get answers of 2 pi on 3k and pi k. So at first glance, none of the options are true. You have the separate options here. And this is wrong because we're looking for a general solution, obviously. So it's not D. And it looks like A is wrong. So, and it looks like B is wrong. So you're like looking for an answer that combines C and D. But the thing is, so the answers, okay, so what you would do is you would get rid of the ones that are obviously wrong. So it cannot be C and it can't be E because, as I said before, you're missing, that's not why it can't be E. It can't be E because K is a member of the reals. So one way to get rid of it is because K always has to be an integer. Not always, but like in general solutions, usually it is. So you can get rid of E by looking at it like that. And C you can also get rid of because you know one of the answers has to be 2 pi on 3k, and K can't be it can't be pi on 3 or something like that because that wouldn't be an integer. So it can't be C. And the last ones you're left with are A and B. So you might be tempted to go with B because it looks very similar to 2 pi on 3k and pi k because looks kind of the same, but 2 pi and k is not the same as pi and k because you can't get 3 pi with 2 pi and k. So answer is actually A because you can't get any of the options. So by like process of elimination, it's A. But also if you look at the expression itself, so 2 pi k on 3, or 2 pi on 3k rather. So that this is the answer we're given, and the answer we need is 2 pi 3k and pi k. So if you look here, you can see that at k is 1, it's 2 pi on 3. At k is 2, it's 4 pi on 3. But at k is 3, you actually get 2 pi, which is kind of what you need to like, so basically it's A because some integer values of k will actually give you the other solution that you need. So yeah, I hope that makes sense. So basically it's just because k is any integer. So the second part of it, so 2 pi k part, can be written in terms of this. Because when k is certain integers, you actually get the same values as you would with 2 pi k. Yeah, so the answer is A. Next question is kind of a hybrid function. It's more addition of ordinates though. So we have this function, which is valid for this domain, and this one's for this domain. So with addition of ordinates, you only take the intersecting domain. So for this one, it would be -3, 2, 2. And the graph, if you add them, so this would be like 2x plus 1 plus x squared plus 2x. So it would look something like, something like this. And both points would be inclusive because as you can see from the domain, it's so this endpoint is taken from gx and it's inclusive. And this endpoint is taken from fx and that's also inclusive, so the whole thing would be inclusive. And the range would be from here to here. So that's why it's kind of important to graph it, because if not, you might think the range is from the endpoint to the higher endpoint, but it's not. It's actually from this minimum to the maximum. Yeah, and if you like, as I said before, graph it, you can see that the minimum is -13. Oh, sorry, no, it's -3, and the maximum is 13. So the answer is D. So for this question, you have a sequence of transformations, and it's going this way. So this is the one that's transformed. And the transformation applied in order to the graph of the original graph could be. So this is kind of trial and error. So you, as I said before, you would start with the bottom, which is a bit coincidental because E is actually the answer, but say we started at the top. So reflection in the x-axis. Okay, so since this is a hyperbola, a reflection in the x-axis actually does the same thing as the reflection in a y-axis. So this negative here could be due to either reflection in the x-axis or the y-axis. So we can't get rid of it just by looking at this so far. So we look at the next thing. So positive axis, direction by 1 unit. So yeah, that's true. You can see that by -1 here. And the y-axis by 6, that's true. Dilation from the y-axis by a factor of 2, that's not true. Somebody's mic is on. Okay, yeah. So translation in the reflection in the x-axis. I'll just write what happens to the graph as it goes. So this A is saying it goes from xy, so there's a reflection in the x-axis, so that becomes x negative y, and then it becomes 1 positive unit, so x plus 1 negative y, and then y-axis, so x plus 1, and then 6 minus y. It's actually like minus y plus 6, but just nicer to take the negative out. And then the dilation in the y-axis by a factor of 2, so then that's 2x plus 2, 6 minus y. And then dilation in the x-axis by a factor of 3, so that's 2x plus 2, 3, 6 minus y. So it gets a bit, takes a while to do this. That's why I recommend starting at the bottom, because like you do less options. So you have x dash is 2x plus 2, so x is x dash minus 2 on 2, and y dash is 3, 6 minus y, so y is 6 minus y dash on 3. So then the next thing you do is just sub x and y in. So 6 minus y dash on 3 is 1 on 2, x dash minus 2 on 2, so 6 minus y dash is 1 on x dash minus 2. So then 6 minus, oh, actually, probably, if I just multiply everything by 3, 18 minus 3 on x dash minus 2 equals y dash. So you can see that's wrong because the y translation is 18 and not 6. So in the same way, you'd kind of do everything, but like I said before, if you start at the bottom, the answer is more likely to be at the bottom because the only way to do the question is by in this case trial and error, but I guess you could also like rewrite this in terms of x dash and y dash. So you would be like x dash minus 6 on minus 3 equals 1 on x dash minus 1. And then you would get y equals minus 3 y dash minus 6. And you would get x equals 1 on x dash minus, oh, no. You just get x dash minus 1. So then you can see the transformation that's happened is 1 in the positive direction. And this one's a bit hard because you would have to divide by y, which seems wrong. But yeah, the only problem with doing it like that is, again, this reflection. Because it's a truncus, it could be in the x or y. So we don't know. So that's why I would do it as trial and error. But yeah, so just start from the bottom and you should get E. So next question is simultaneous equations. So for this one, you just write it as a linear equation. So ky is a minus 2x, y is a minus 2x on k. So that's the first one. And then the other one is y equals 7 minus kx on 3 is the second one. So if they have no solutions, that means the gradients are equal, but the c value, or like the y-intercept, I guess, y-intercept is not equal. So in this case, the gradient would be, if the gradients are equal, it would be negative 2 on k is negative k on 3. So you could see it's going to be k is plus or minus root 6. And we don't want the y values, y-intercepts to be equal. So it's going to be a on k equals not 7 on 3. That means a is not going to be equal to 7 on 3k. And then now you can just check the answers. So if k is equal to root 6, so you can first look at the k values. So they have to equal plus or minus root 6. So you can get rid of d because it's saying that k is not equal to plus or minus root 6. And you can get rid of a and e because you know there are two options. It could be plus or minus root 6. So now you're left with b. And then you can figure out what a is when k is plus or minus root 6, but you don't really have to because they're kind of mentioning the same thing. And you know that a is not going to equal a value, so it's going to equal like a lot of values except for one. So you can, without even like working it out, you can see that it's going to be the answer that has a is the reals except for something, and not when a is equal to something, because that would be when there's infinite solutions. So that's why the answer is C. But yeah, even if you subbed in k is like plus minus root 6, you would get the 14 on root 6 option, and you would know a can't equal that. So it would be C anyway. But just to save time, like just you can look at the answers. So graph of the derivative of the inverse has, and it's again trial and error. So we need the derivative of the inverse. So first we have to find the inverse. So that's going to be x minus 1 on 2 e to the power of that. 1 minus that, the whole thing divided by 4. So that's f inverse x. And then we need the derivative of that, and that's going to be negative 1 on 8 e x minus 1 on 2. You can just chuck that into your pairs. So now we're looking at this function. The things you need to know about this function is that it's a exponential, and we know that exponentials, this is a negative 1, so it's going to be like, it's going to be like this. So we know that it's never going to, it has a vertical asymptote, horizontal, sorry, at y equals 0. That's actually really helpful because you can already get rid of a bunch of options. You can get rid of D, B, and A because none of them mention the y equals 0 asymptote. And you can also get rid of E because we know that it does not, in fact, have an asymptote at x equals 1 on 4. So the only option really is C. You don't even have to check this, but obviously you would just put x equals 0 onto here, and you would get that. You can see like from here. So next question, use as a transformation question. So we have a curve with the equation this, and another curve with the equation this. and this is the end curve. So this is the start curve. So I started with the transformation matrix. So x dash is x plus 2, x is x dash minus 2, so y dash is y minus 3, so y is, oh, sorry. That's actually the trick of the question, is that it's not 1, 0, 0, 1, it's the other way. So it's actually a reflection in the x-axis, because if you multiply out the matrix, you actually get x dash is y plus 2. So y is x dash minus 2, and y dash is x minus 3. So x is y dash plus 3. So just don't do what I just did. Make sure you check the matrix properly, because it's not 1, 0, 0, 1. It's 0, 1, 1, 0. But yeah, and then you can just chuck that into this function. So this would be y. So x dash minus 2 is a, y dash plus 3 minus b. And obviously a and x have been swapped around, so you can rearrange it. So x dash minus 2, I'll change x dash and y dash to x and y for now, but just know that it's x dash and y dash. I'm just rewriting it. Cube root, and then you can see you're going to have plus b and minus 3. So y equals, and then all you have to do is compare this and this. So you can start with the easiest one, that would be the y translation. So 1 is b minus 3, so b is 4. And you can see you've already got rid of options A, B, and C. And then if you look at option E, you're not going to want to know what A is, because A is 1 for everything. So you're going to check what C is. So C is here. So x minus 2 minus C is going to have to equal, minus 2 minus C is going to have to equal 0. So C is going to be minus 2. So that's going to be E. So now we actually have a function in a function. So this is gonna, these kind of questions you have to be paying attention, because there could be something that you're missing. So the trick, I guess, not really with this question, is to realize that this can be factorized to x plus 1 squared. And also to realize that this is a function in a function itself, and you're going to put that into another function. So it's kind of like a combination of 3 functions. So first thing you can do is check g f x. So g of f of x. So it's going to be log 2. This is why it's important to rewrite fx as that, because if you leave it in its original form, it's going to be really hard to figure out what g of fx is simplified. But if you write it as e to the x plus 1 squared, you can take out the exponent, as we've learned before. So then it becomes x plus 1 squared log 2e. Oops. Yeah. But the problem with that is you can't really see an answer, but you know that rule where you can take out the you can rewrite PQ as, say, log CP on log CQ. We're going to use this rule. And so you can't really tell which base to use so far, but the way to get the answer would be to use E, because you wouldn't know that starting from the question. Once you got to this point, you would kind of leave your answer here and then go to check the other thing. So the other thing is range. But I'll just keep going for now. So x plus 1, oh, sorry, I already did it. And then log EE. Oops. Log E2 EE. So the range would be So we would have to draw that table with f and g. So domain, range. So the domain of fx is all real numbers. You can see there's not really a restriction, but the range of fx, so as I said before, fx is a function in a function of itself. So the normal exponential graph would look like this, e to the x. This would be 0, 1. But the problem with fx is that kind of like the inner function of fx is x plus 1 squared. So that looks like this. So this is negative 1, 0. So the range of x squared plus 2x plus 1 is actually 1 to infinity. I mean, 0, sorry. You can see from here, it doesn't have any negative values. So that means e to the power of x, the range, I mean, like the numbers input into this will only be 0 to infinity. So we don't actually have this part of the graph. So then that means that the range of fx is 1 to infinity. So for domain of gx, we know inside long functions, it can't be negative or 0, so it's going to be 0 to infinity, and the range of log functions is all the reals. So yeah, and then we actually do the hybrid function, not hybrid function, we find the range of the new gx. So the range of fx is what we're inputting as the new domain of gx. So the new domain of gx would be these values here. Would be, well, it would actually be r. So you put all real values into f, and then you would get the range of f, and then you would put that into g. But the overall domain is still this one, but technically the domain of g is this one. I hope that kind of makes sense. So the numbers you're inputting is here, but the range is technically r. So to figure out the range of g now, you would take your normal log function here. So this would be 1, 1, 0. So you can see that since the range is 1, 0, we wouldn't have this part. So the domain of this graph is now 0 to infinity. So that means we can get rid of options A, not C, D, and E. And then if you look at where we stopped before, we got up to this part, and then we got stuck. But we didn't actually need to simplify it further, because the answer, let me just double check that this is the answer. Yeah, so we have matched our ranges, and B doesn't have, it's missing a whole part. So it's not B, so the only option left is C. So next question is question 10. So which of the following is true? So you would start from bottom because this has got to be trial and error. So to check this option, and for these questions, always make sure it's asking for which one's true, not which one's wrong. So if it has 3 x-intercepts, you would just let this equal to 0 and solve for x. To make it faster, I recommend putting it in decimals, because you only need to know how many solutions there are, not what the solutions are. So it might make it faster, might not, but yeah. So this one is not true. Sorry. To check this one, just easy. To put the derivative of that, but you don't actually need to waste any time, because you can see that they've carried the -6 onto here, and you know the derivative of -6 would be 0 because it's a constant. So you can get rid of this one without even putting it into your CAS. The graph of Qx as stationary point of inflection. So for this one, you would try Q dash dash X equals 0. But the only thing is sometimes there is an answer for this, but it might not be a stationary point of inflection. So if you find this is true, just leave it for now and maybe find another one that's true, because this condition holds true. So so all points of inflection, for all points of inflection, this happens, but not every time this happens is there a point of inflection. Yeah, so it's a thing. So if you get this as true, just be careful, because it might not always be a stationary point of inflection. So check the other answers. Q x minus 1 is a factor of q, so just chuck 1 in there, and if it equals 0, that's true. Doesn't turn out to be true. The answer is actually A. So for this one, you would just solve q dash x equals 0. So the starting from the bottom thing didn't really work for this question, but for most questions it would. So question 11 is testing chain rule. So you would get f log, let's try it, ln 2x d, so d of the middle function times d ln of the denominator of the middle function times the denominator until you get to x, or something that's easily differentiable. So we know this one is ln 2x. We know this is just 1 on x because we just ignore the middle part for now, and we know this is 2. Sorry, nope, it didn't make it better. This is 1 on 2x because we keep the middle part because it gets cancelled out in this part. So we cancel that out, and then it's just 1 on x. F dash ln 2x. The answer is C. So for this question, so stationary points, and the thing you need to look at is the answers. So you can kind of see we have AB constant thing going on. So you should be like kind of maybe considering the discriminant. So that's what you need to do for this question. And then you should, like, that theory kind of should be supported if you look at the question, because if you differentiate that, you'll get 6ax5 plus 5bx4 plus 4x3, and you can actually get a quadratic from this if you factorize out the x to the power 3. So thing to know is that when f dash x equals 0, you already have a solution here, so that's when x equals 0. So for this one, you're just looking for 2 solutions, so that means the discriminant will be greater than 0. So just by this fact, you can get rid of B, C, your B and C, because it has to be an inequality that's not equals. And then to figure out the rest, you have to use the discriminant on your cas. And if you just do b squared minus 4ac minus 4ac is greater than 0 using these values. So b is 5b. Oh, that's unfortunate, but it just happens to be called b as well. But yeah. And a is 6a and c is 4. Just put that into your cas and you should get D. So the next question is also trial and error. So we start from the bottom. So it's incorrect to state that fx equals 0 at 4 and negative 4. That's correct because there's x-intercepts at those points, so that's correct. F dash x is greater than 0 for this interval, so that means it's going up. So yeah, that's true. And yeah, that's true. And then we check the endpoints. They're not inclusive, and that's true because this is a greater than sign, not a greater than or equal sign. So that one's also true, so it's not the answer. Strictly decreasing, so yeah, it's going down, it's decreasing. And it's including, and that's appropriate for the strictly decreasing part. So it's not C because that's also true. So the graph of the derivative of f is strictly increasing for this. And you might think this is true because it looks like, yeah, it's increasing from negative infinity to 1 and 4 to 0. It's increasing, yeah, but it's not because it's the graph of the derivative of f, not just the graph of f. So to do that, you'd actually find f dash x, which would be hard to do because you don't know the equation of the graph. But also you can see that for negative infinity to -1, so the graph is getting less steep. So you can tell that it wouldn't actually be increasing. But yeah, if you saw this and you were like confused as to tell whether if it's true or not, you would just go to part A and you check that and you know A is correct. So by process of elimination, it would be B. But yeah, just be careful with the wording of the questions. Average function value is just easy. Just put that into your CAS. Pi on 2 minus 0, pi on 2 to 2, 0, y dx. The answer is B. So for this question, you would split it into this -1 to 6 fx dx. And you know when you swap the terminals, it becomes negative. So if 6 to -1 fx dx is 3, then -1 to 6 fx dx is -3. So this one you would put into your CAS. I'm pretty sure that's a 6, sorry, -7 minus 2, and this is -3. So -7 plus 6 is -1. So question 16. So for this question, it might look like there's not an answer because it looks like you need 1, 2, 3, 4, 5, 6 y like height values for the boxes. So you might look at the options and see that none of them have 6 and think they're all wrong. But what you need to see is that the area of some of the boxes, these two and these two, are the same. So the area would be twice this box plus one of these two. So you're looking for an answer option with 4 y values. So automatically you can get rid of C, for example. And the other thing you know is that each width would be pi on 3 because you can see this is pi. So generally it's equal distribution, so it would be pi on 3. So you can get rid of anything that doesn't have like a x value for the box, so that would be B. And A is wrong too because so it has pi on 3, but it's multiplied by 2, meaning it's multiplied each of these like areas, so some of these boxes by 2. But we know we only need the same boxes for 2 of these, so you know A is wrong. So then you're left with D and E, and you just have to find which one has chosen the correct boxes to multiply them by 2. So we're looking for either this y value and this y value, or this one and this one. So that's when it's minus pi on 3 or minus 2 pi on 3 or pi on 3 and 2 pi on 3. But it has to be like this one on this one. Like it can't be, both of them can't be negative pi on 3 and pi on 3 because then you would have 4 of the same box. So looking at the options, D is twice of this box. Oops. Twice of this box and twice of this box, and the other ones that it's adding is g of 0, so it's adding this box, and g of pi, so it's adding this box. So you can see it's got all of the areas because these two are covered by these two. So that's correct. But if you check E as well, so it has 2 of g minus pi. So immediately you can get rid of E because this is, you need the right endpoint, so you need this one, not this one. So anything that's a g of negative pi is wrong. So just because of this part, you know the answer is going to be D. So for this question, we have a cubic graph. So we know cubic graphs can look like either like this or they can look like this. But for this question, we know that A, B, and C are positive real constants, so it's not going to look like this. And the next thing we know is that by looking at the form, we can tell this is going to be a turning point, and this is going to be an x-intercept. So negative c here, and this is going to be b. And if it's going to be a positive cubic, it's going to look like this. So the area bounded by f and the x-axis, that would be this area. So we're just looking for the integral that has that one, and that would be e. So Vanessa is a netball player. Probability is this. P is 0.7. Number of shots that she needs to make more than 20 goals is greater than 0.95. So probability that, say, x is greater than 20 is greater than 0.95, and we need to find out. So P is 0.7, and we don't know what n is. So for this question, you do need to find n, but looking at the answers, you can tell that it's a bit quicker to do trial and error. You can just test 35, 34, and 36 rather than having to find n on your own, because it has to be obviously one of the answer options. So for this question, you would just do binomial CDF, chuck in 20 to each value and see which one gives you a number greater than 0.95, and you'll find the answer is D. Oh, sorry, not D, B. The other thing that might be annoying if you actually find a value of n is that it's going to be like, I think it's 34 point something something. So like, you don't know whether to round up or round down. So like just doing trial and error kind of removes the hassle. So last question is question 19 in multiple choice. So we have a mean of 40 and a variance of 9. So that means standard deviation is 3 because it's the square root. And there's a z value, and the probability that z lies between -3 and 1. So this one. So basically for this one, we just have to convert it to, well, looking at the answer options, x values. So remember, z is x minus mu on sigma. So that means x is z times sigma plus mu. So if we start with -3, 3 plus 40, so that's going to be 31. And if we do 1, so z is 1, 3 plus 40, so z is 43. So that means this is equal to probability that x is between 31 and 43. But as you can see, that's not an option. So if this happens, like, don't panic. It just means that there's probably a trick, or you have the answer but not in the right form, or like something like that. And the thing with this question is that it's standard normal distribution, so there's always some sort of symmetry. So the area we're looking at right now is this one. But you can tell that would actually be the same area as this one. So instead of going from -3 to 1, you can also go from -1 to 3. So this would be equal to -1 to 3z. So then you would again convert the z options to x's. So x equals -1, 3 plus 40, so x is 37. And then 3, so 3 plus 40, so x equals 49. So that means this is equal to the probability that x is between 37 and 49. So the answer is B. For this type of questions, they often actually use the blue part. They don't use the actual values they've given you. So it's probably quicker to start with the symmetrical, other part rather than what they've actually given us. So next question, there's cafe. So I'm just going to call flat whites F. So there's 0.55 people buy those, 0.35 buy cappuccinos, and 0.1 buy short blacks. So first thing to notice is that this adds up to, so we have 9 here, so adds up to 100%. 1, so that means all of the customers buy at least like one of these. So if they buy a flat white, then there's a 30 chance they'll get a muffin. So muffin, no muffin. So if it's buying a muffin 0.3, then not buying a muffin is 0.7. Same thing for the cappuccino, except it's 0.4%. And the short black is 0.6. So what's the probability they bought a short black given they bought a muffin? So to do that, we need to know the probability they bought a short black and a muffin, and then divide it by just the muffin. So the probability they bought a short black and a muffin is this branch here, this one. So that would be 0.1 times 0.6. Actually, it would just be 0.6 because on a oh no, I was right. It is 0.1 times 0.6. I have just written it wrong in my working out, but yeah. And the probability that it's a muffin would be this branch. So this branch plus this branch plus this branch. So it would be 0.55, 0.3 plus 0.35 instead of 5. Yep, 0.35, 0.4 plus 0.1, 0.6, which is the numerator. That comes out to 0.6, no, 0.06 on 0.365, I think. But you need exact values, so if you do that, you just get A. And that's multiple choice. So short answer question number 1. So we have a function, and write down the derivative of the function. So I guess the easier technically way to do this would be to expand this, but this like the stuff with less working out because you've only been given 2 lines is just to use the chain rule. So f dash x is, because a is a constant, you can just leave it out for a second. And to do the multiplication, I forgot what it's called, but yeah, the multiplication rule, the product rule, yeah. So you would leave this one alone and then multiply it by the derivative of this one. So x minus b to the power 2, and then you would have to add this time the derivative of that one, but that would actually just be 1, so just leave it like that. But it asks for fully factorized form, and you can see you can factorize a and b minus x minus b squared. So you do f dash x equals, f dash x is a x minus b squared. And then the common thing here is 3x minus 3c. The common thing here is x minus b. And then you can collect some like terms. In this case, it's just the x values minus 3c minus b, and that's your answer. So for question B, it's verifying by substitution. So you would take your fx function and substitute in the given values. So then you would get, so fx is -12 x plus 3 squared, x plus 1 squared. So the first thing you need to do is verify that the x-intercepts are -3 and -1. So you let fx equals 0. 0 equals negative half x plus 3 squared, x plus 1 squared. So this is also kind of a way of checking whether you've done part A right, because if you haven't, you probably won't get, like you won't be able to verify these. But with this one, you can kind of easily tell that by null factor law. When x equals negative 3, x equals 1, f equals 0, therefore there are x-intercepts. The other thing you need to verify is that f dash x equals 0. So f dash x equals from here, negative half x plus 3 squared, 4x plus 0, which is just 4x. So f dash 0 is negative half 3 squared, 0, 0. Therefore, f dash 0 equals 0. So say the nature of the turning points for which, for y equals fx. So y equals fx, to find stationary points, just let f dash x equals 0. And from this question, we can tell easily that it's x equals negative 3, x equals 0. So to tell the nature of the stationary points, I think for 1 mark, you can pretty much just write what they are. So you would do that by looking at your CAS. So just graph the function of fx. So at x equals 0, it's local max. X equals negative 3, it's point of inflection. But if you were worried that like maybe you needed to do something else for the mark, then you would just do that table of values. So x is less than negative 3, x is negative 3, x is between, x is between 0 and negative 3, x is 0, and x is greater than 0. And if you filled out that table, you would get plus 0, minus. So the graph would look like this, and then you can see that like just confirms these two, but now you have some working out in case you're worried about the marks. So next question is tangent to the graph also intercepts it at 3 other points. So the thing with this one is you have to find the tangent. I didn't write it down when I was doing it, but there's that function in your CAS that easily does it for you. It's in the calc menu. You just look for tan line. So once you find that, you would equate it to fx. It's not just fx. Make sure to read what they've told you, because hx is x times fx. So you just let that equal this, and you would get the points root. So it would be here, root 2 minus 13, root 2 on 2 minus 16. You would get this one, which is 4 and 10, and you would also get here, which is, sorry, it's not that one. It's actually, it's not the point where it's tangent. It's another point, like just, it kind of looks like the same place, but it's not. Negative root 2, 13, root 2 on 2, minus 16. So now it's asking to sketch the perpendicular line. So the only issue with this is that it kind of looks like a straight up horizontal line, but it's not. It kind of looks like this. Yeah, so that's the only issue with this question, is that just like making sure your graph doesn't look like it's a flat line. And it does look like this. Make sure you don't draw any x-intercepts, because if you solve for x-intercepts and y-intercepts, you'll tell that the y-intercept is below the x-axis and the x-intercept is not in the domain of in the graph. So just make sure to check those. So find the coordinates of the point when perpendicular graph intersects this. So you just let y equals solve 2 on 13 x minus 35 on 13 equals hx. Just the calc question, so you get -2, -3, -0.21, this one, and 1.07, and -2.53, as per the instructions to write the non integer ones as decimals. So write down the sum of definite integrals that gives the area enclosed by the perpendicular line at x equals 2. So it's asking for this area and this area. So to do that, just write area equals, just make sure you get like aware of which graph is on top of which, as well as the terminals. So it would just be 1.07. So starting from the right, 1 hx. I'm just going to write y would be the equation of the perpendicular line, and -0.21, -2, y minus hx. So find the area, you just chuck that into your CAS and you get 12.1 to 1 decimal place. And make sure to write the units because they haven't given us any units. So now there's another line that's parallel to the tangent. And it goes through 3 points on hx, and one of them is -half. So the first thing we know is that since it's parallel to the other line, the m is going to be -13 on 2. So make sure you realize it's not parallel to the perpendicular line, it's parallel to this line. So you don't even have to find this equation again because these two lines are perpendicular. So the gradient of this one would be -1 of 2/13. So that would be -13 on 2. And that's all you need to calculate this this equation. So, yep, you don't even have to follow if you don't want to. But obviously you can if you want to double check or something. But the other thing you need to do to find the equation of a line is to have a point, which is convenient because they have given us a point. But we only know the x value so far. So to find the y value, you have to put that into your h graph. So it's going to be -375 on 64. So we know the equation to find a graph is this one, x minus x1. So you just sub this and this point, and you would get the answer, which is -583 on 64. So find the shortest distance between lines. There's 2 ways to do this. Because you know the parallel you could find. So say we have parallel, so that the shortest distance is like going to be the same everywhere. So you could do that by finding like the perpendicular line, which you already have, and then finding the point where they meet, and then like using Pythagoras or something. But just to save time, because it's only worth 2 marks, that would take a while. You could just find like a function. So you could do d is x1 minus x2 squared plus y1 minus y2 squared. So in this case, you would do this graph. Where is it? This one. So that would be negative 374 and 64 minus x1. Sorry, it's wrong. Sorry, you would start at the point where it has it meets the hx graph. So x1 would be negative half, and then x would be just x, because you're trying to find a function, so it would just be x. And then y1, so at negative 1, we figured out it was negative 375 and 64 minus y2. But y2 is actually the function we found before. So that would be negative 13 on 2 plus 16. But remember, it's not this one. It's a merge of, where's, oh, I don't think I wrote it down. But it would be like this function, but the tangent here instead of, not the tangent, the perpendicular line, because we're trying to find when that's a minimum. So there'd be 16 squared, and then you just put that into cas, dmin, and you would get 1.05 units, I guess. So now we have this equation, and we're trying to change the form. So by looking at the question, you can tell the one thing that's changed is that they've added this to the numerator. So you can kind of start there by multiplying both the numerator and the denominator by the same thing. So CT is 1000, 1 plus e to the negative times the same thing, because that's the only way you're not changing the actual equation. So 1000, and then we have E15 plus E15 t minus 10 times E15 t minus 10. And we know when we multiply this, we add them. So maybe I'll write here 115 t minus 10 plus e negative 115 t minus 10 plus 115 t minus 10. So since you're like minusing the same thing from the other thing, this is going to be 0, and e to the 0 is 1. So this whole thing goes to 1. So then it simplifies to 1000 e115 t minus 10 plus 1. That's what you need. So use the quotient rule to show that blah, blah, blah is true. So C dash T is, sorry, 1000. So I think for this question, that's why you needed to, oh, sorry, I forgot a whole part of this. 1000 E15 T minus 10, E15 T minus 10. So that's why you need it in that form, because otherwise you would have a constant. So to do the quotient rule, you differentiate the top. So that would be 115, and then you leave it alone. Then you multiply it by the denominator. And then you leave the top, minus. And then you multiply it by the differentiated version of the denominator. And then you square the bottom. With this, you can kind of see that you have the same thing here. And if you expand it, you would have the same thing with this one term and this multiplication. So if you add those two, you would actually get 0. So that's why this simplifies to, okay, maybe I'll just actually expand it so you can see what's happening. So this is going to be 200 E115 T minus 10. But you would times it by the same thing. So it becomes squared plus suddenly forgot what I was doing. Sorry. Plus 200 E105. Okay, I'll just write E105 T minus 10 plus 200 E105 T minus 10 minus 200 E105 T minus 10. So you can see these cancel, and then you have 1 on 1 plus E105 T minus 10 squared. So we're almost at the answer. The only problem is the numerator, and it looks like I've forgotten something. I have forgotten that this, where is it? Yeah, I forgot to multiply by the actual the rest of the function. So 1 on 5 T minus 10. So this is not the part that would cancel out. So this would be 2 on 5, because like I said before, when they multiply, they add the exponents. 200 E 1 on 5 T minus 10, and then minus. So as I said before, the 1/5 and 1,000 becomes 200, and again the exponents add T minus 10. So then it's actually these two that cancel, and then you're left with the answer, which is 200 E 1 on 5 T minus 10 on 1 plus E 1 on 5 T minus 10 squared. So hence show the graph of CT has no stationary points. So for this one, you just have to say that C dash T is 200 E 1 on 5 T minus 10. Just rewrite this. So at stationary point, C dash T has to be 0. Therefore 2000 E 1 on 5 T minus 10 has to be 0. But since, so E 1 on 5. But since E 1 on 5 T minus 10 is greater than 0 for all of T is an element of real numbers, therefore C dash T never equals 0 and has no stationary points. So basically you just have to show to the examiners that you understand that C dash T is dependent on this equation, 2000 E1 on 5 T minus 10 equals 0. So if this ever equals 0, then there will be a stationary point, but as you can see, it's an exponent, so it will never equal 0. So you just have to explain that, and it should be fine. Maybe you want to draw a graph to show, to prove why this is true, but yeah. So find the value of T for which has a maximum gradient. So maximum gradient, you could do C dash dash T equals 0. The only problem is that sometimes it gives you the wrong answer. So the more consistent and accurate way to do this is just to graph the gradient. So graph the function of C dash T, and you can see what it looks like and find the maximum from there. And you should get that it happens when T equals 10. and the maximum gradient, so just sub C-10 and get 50. So state the transformations that will take this graph to this one. So if this is the transformed graph, then this is in terms of y dash and t dash. So we'll start with the normal graph. It's going to be this one. And the transformed one is y dash is 1,000. So since it's 1,000, I'm just going to bring it under here. So it's y dash on 1,000 is E1 on 5 t dash minus 10, 1 plus E1 on 5 t dash minus 10. So now we know that, so we can equate the t dashes to the t values and the y dashes to the y value. So we can start with y, get y dash on 1,000 equals y, so y dash is 1,000 y. And the other one is that t equals, oh, what have I done? Oh, sorry, I expanded it. So 1/5 t dash minus 10. So 5t equals t dash minus 10. So t dash is 5t plus 10. But now we have to word the transformation. So we'll start with y because it looks the easiest. So that would be a dilation by a factor of 1,000 in the, oh, sorry, make sure to write in, I mean, not in, from. That's the standard wording, I guess, from the x-axis. And then always do dilations first when describing stuff. So for x, start with dilation instead of the translation. So dilation by a factor of 5 in the y-axis. And then lastly, do the translation. So translation of 10 in positive x direction, or you can write x-axis or something like that. So for the next question, just graph it onto your CAS. And you can see what the graph looks like. The only problem is that there is a horizontal asymptote at y equals 1,000. And your CASs don't really give asymptotes until you go into conics. But conics only takes specific graph forms. So for this one, you wouldn't be able to find what the asymptote is. So the only way to see what it is to see what happens when t goes to infinity. So when t goes to infinity, so there's kind of two parts. We have the exponents here. So when t goes to infinity, you can see those values also go to infinity. So it'd be 1,000, 1,000 on 1 plus infinity. But you know, when you divide by infinity, the number's going to get very small. So if you split this into, say, 1,000 plus 1 plus infinity plus infinity on 1 plus infinity. Okay, it's kind of hard to explain, so maybe I'll use the original equation they gave us, so without transforming it into that. So CT was originally 1,000 on 1 plus e to the negative 1/5 t minus 10. So this time this equation looks like this. So this is ET, this would look like this. So this would go to negative infinity. So if e to the power of blah goes to negative infinity, then this whole thing goes to negative infinity. So that means you're dividing it by numbers that get closer and closer to, so say 0, but not 0. So that means you're getting closer and closer to 1,000, because like you're dividing it by less and less. So like say for example, you go from 1,000 divided by 10, 1,000 divided by 9, and so on and so forth. So the lower number you get, like the closer you're going to get to 1,000. But since it's 1, and this will never be 0, so like it'll get lower and lower, but the whole denominator will never be 0. So that means and it like this part will never be 0, and the whole thing will never be 1. So that means it'll get really close to 1,000, but it won't ever be 1,000. So that's why there's an asymptote there. So the graph's like, if you graph the endpoint and you start with, it asks you specifically to graph the gradient when the gradient's a maximum. So that would be at 10 and 500. So that would be this point right here. So you can kind of base the rest of your graph around that point. So just make sure it actually looks like the maximum gradient is there. It doesn't ask you to write what the endpoint is, but if you want to know where to start your graph, you can kind of guesstimate how much that is. And yeah, just make sure to write the asymptote, and don't have your our school teachers always tell us that sometimes they have people drawing graphs like this, like maybe at the end, like it'll kind of go down away from the asymptote. So don't do that, because they'll take a mark off. Always make sure it's approaching, and if you can't approach it anymore, then just stop drawing. Yeah, anything, just don't make it look like the graph's headed away from the asymptote. So this question, now you have to explain why the asymptote is there. So I chose to say, no, it will never reach 1,000, because, oops, so as t goes to infinity, e to the negative 1/5 t minus 10 goes to 0. So that means c of t goes to 1,000 on 1 plus 0. So hence it will approach 1,000 but never reach. So I chose to explain it like this, but I'm pretty sure the answer said you could literally just write that there was a horizontal asymptote, and I think they would have given you the mark. But yeah, either way should be fine, as long as you explain why it'll never get there. So social distancing, so this question is kind of based on corona. So social distancing will be lifted in that town after the average rate of change per day is below 1 case per day for 10 consecutive days. So important things here is average rate of change, below 1 case, so for 10 cases. And need to determine the day the restrictions will be lifted. So the thing with this question is that it asks for average rate of change, but it's going to be hard to do, because for average rate of change, you can only really figure it out if you know exactly what range of values to do it from, because you would do like FB minus FA on B minus A. But the problem with this question is that we're trying to find B and A. So it'd be, to find B and A using average rate of change, we'd have to like literally test every single day. So we'd have to go day by day. We'd have to do like F46 minus F45, 46 minus 45. So that would take forever. But what we do know is that the average rate of change is kind of an estimate of the actual rate of change. So we kind of use it the other way around. So we're going to use the actual rate of change to estimate the average rate of change. So if we're trying to find, what we're trying to find is when average rate of change, so A rock is 1 on 10. So to do that, we're just going to find when, C dash T is 1 on 10. So we're going to find the exact value. And then we're going to like use the numbers around that to do trial and error rather than starting from the beginning, because that would take way too long. So if you do C dash T equals 1 on 10, you get T is like, 47 point, I think that says 999. Handwriting could be way wrong, but something around 47. We don't actually need this value. We just need to know like what values it's around so that we can start doing trial and error. So if you get this value, you might want to check 46th day, 47th day, and 48th. Yeah, we just needed like a estimate, so we can use like some of the values around it. To test each one, since it's per day, you would have to check. So you would do, to test the 46th day, you do f of 46 minus f of 45, 46 minus 45. The denominator should always be 1 because you can't really, it's per day, so it would just be today's day minus yesterday's day, so it's always going to be 1. So like that, you would test 46th day, the 47th day, so 47 minus 46, and the 48th day. But you would see that none of them actually fit the criteria. I'm pretty sure they're all greater than 0.1. So, but you can see that it decreases with the increasing days. So the next one, would be to try 49th day. And this one would be the one that actually gets below 0.1. So that's the first day that it's below 1 case per day. So the next thing you need to do is find the day the restrictions will be lifted. So that's after 10 days of this. So if the first day is the 49th, then the day the restrictions will be lifted is the 59th. So it'd be the 59th day. And that's the answer. So kind of starting this question, the graph that, my 5 looks like a 6. So starting the question, the thing you would have to look at first is the graph you drew here. Because you can tell that if we're looking for the time when the average rate of change falls below a certain number, we're going to be looking at this part of the graph. Because for this part of the graph, this green part of the graph, that's when the average rate of change will always be increasing. But we're looking for when the average rate of change will decrease a certain number. So for like the blue part, you could see the gradient's getting like less, but for the green part, it's getting more. So we can automatically tell we're looking for a number greater than 10. And that also means that like there's no tricks or anything. As the days get higher, we're expecting the rate of change to get lower. That makes sense because we saw that with our trial and error. So, and that also means we can be sure that just adding 10 will be correct. We don't have to worry about it like one day it gets higher, one day gets lower, one day gets higher, one day gets lower, because the change of the gradient is quite stable, and we can be assured that it gets less and less every day. So we can be assured that it stays below what we need. So yep. So next part of the question is probability. Oh, I just dropped part of paper. So find the probability that chosen female dog will have gestation period less than 61 days. So they didn't define a variable for this question. So we kind of, I had to define one myself. So I said, let G equal period of gestation. And the first question is pretty easy. It's just chuck it into your CAS. And she gets 0.1175. So now we have a given function. So given that it's less than 61 days, what's the probability that it's more than 58 days? So probability that G is greater than 58, given that G is less than 61. So remember the numerator would be the intersection of these two things. So it would be between 58 and 61 over less than 61. You could just put that into your cas. For the bottom part, you could also replace it with your answer to part A, because it's the same thing. 2283, and you would get 0.991 according to the 3 decimal places requirement. So part C, we have 30 female dogs and probability that 5 or more less than 61. So now we've moved on to binomial. You can tell by the introduction of us, like sample number. Don't get confused with sampling though, not the same thing. So we have n is 30 and the probability, so the p-value is the probability that G is less than 61, which we found in the previous questions. And n is 30. So the probability that we have to redefine a new variable. So this one I just said let x equal amount of female dogs with G less than 61. So now we're doing probability that x is greater than 5. The trick with this question is that it's binomial. So if it's so in like continuous distribution, it doesn't really matter if it's greater than 5 or if it's greater than or equal to 5, because they'll both give you, like, technically this doesn't exist. It's always greater than or equal to. But in binomial, if it's greater than 5, that means it can't be 5. So it's always better to rewrite this as x is greater than or equal to 6, so that if you're being quick and you put it into the calculator, you don't accidentally put 5 as your lower boundary, because your lower boundary would be 6. Because when you put the lower boundary into your cas, it includes that value, so it's like 6 to something, not 6 to something. So that's why just easier to rewrite it with an equality that has equal sign in it. But yeah, so just do that with p value here, n value here. And you should get 0.1130. So write down mean and standard deviation for distribution in part C. Give your answer to 3 correct to 3 decimal places. So by distribution, it's kind of alluding to the fact here that you moved on to binomials. So we know that mu is n times p. Same values as before. This would be 3.525. And sigma is square root np 1 minus p. So same values as before. That would be 1.764. So what's the probability that, I'll just read this part. So for a week, so this is for a week. So, and this is for every day. So she either buys no toilet paper, buys 1 packet, or buys 2, or buys more than 2. But for this question, we're only interested in up to 2 packets. So the probability that she'll purchase 2 packets of toilet paper in the first week. So we have 3 options. We have that she purchases both on the same day. So we have 2 probability, only 2 packs. We have the probability that she purchased them both on the same day, so 2 in 1 day. And we have 7 days of the week that could happen on. And then we also have the probability that she chooses 1 on 2 days. And we have 7 choose 2 days that could happen on. So this is also 7 choose 1. but that simplifies to 7, but yeah. So yeah, you just put this into your cas. So the probability of, so like if you expand this, it would be 7 choose 1, p to the 1, and oh yeah, this is a special case because this would usually be 1 minus p, but it's not because you actually have this extra part, and all of these probabilities don't add up. I mean, they do, but you have this special case. So just because she doesn't purchase 2 in 1 day doesn't mean that's 1 minus p, because we already know that she's not going to purchase more than 2. So the only options are these two options. Oops. So, I mean, for this one, it's actually 0.7 because she only purchased 2 in 1 day. So I have to say. So usually in binomial, there's only 2 options, and there is only 2 options in this question, but the 2 options for this part and this part are different. So that's why it's a bit tricky. So for this one, the 2 options are that she buys 2 or she doesn't buy any. So the p-value would be 0.051, and the probability that she doesn't buy any is 0.7, and that's the rest of the days. This is 7, by the way, and this is 21, I believe. And so for this one, it changes. So the probability we need is that she buys 1, so that's 0.2 for 2 days. And the other option is that she also buys none, so that would be 0.7. So you can see the p-values have changed, but the other value hasn't changed. So like the p1 minus p thing doesn't apply here. So like always be wary of the question. But yep, so you just simplify this, and you get 0.1824. So we have Nadia's puppy Milo is doing some stuff with the toilet paper. So for this question, I drew a Carnot map. It took a lot of working out, so maybe don't draw a Carnot map, but it's probably the easiest way to do the question. The only problem with it is that once you find the values, you might have to draw another one, but if you do your map nicely, you probably won't. I just have very messy handwriting. So the first thing we know is that if he's gonna play with the paper and eat his dinner, it's P, so that would be the intersection of those two, so that's why it's there. Next thing is that not eating his dinner, but playing with the toilet paper, so that would be not eating dinner is this box, so 3p minus 2 on 3. And the other one is eating his dinner but not playing with the toilet paper, so that would be this box, so 7 minus 8p on 8. So the events of playing with the paper and eating dinner are independent, so find the probability he'll do neither. So we want the answer in here. So like is it a trick? I'm not sure if it's a trick, but the thing with this question is that there's actually a couple of things. So the first thing is to find this, you're going to do some list the things you know, I guess. So the first thing you're going to realize is that it really like mentions that it's independent. So we know if it's independent, the probability of P times probability of D is probability of P intersection D. So this is P, but we haven't defined these two things. So we might go back to our Carnot map and define them. So the easiest way to find probability of D would be to add these two things. And that's kind of where the trick comes in, because once you add those two, the p-value actually disappears and it becomes 7 on 8. So then we immediately know this is 1 on 8. Yep. Same thing, unfortunately, doesn't happen to this one. It goes 3 pi on 2 plus on 3 plus 3 pi on 3. So that's 6 pi minus 2 on 3. So nothing crazy happens to this one, unfortunately. 6 pi minus 2 on 3, and this one would be 1 minus, but we don't really need to fill in that box because like we don't need it for anything. So what we do here is we sub those values in. So probability of P is 6 minus 6P minus 2 on 3 times 7 on 8 is P. And you can solve for P here and you will get P equals 7 on 9. So now the one thing we need to do is find what's in this box. So the probability of, so now that we know P is 7 on 9, we can actually replace some of the things in this box. For example, this would be 7 on 72. This would be 7 on 9. This would be 8 on 9. This is what I was saying when I said the cardinal map. It's a bit annoying because I'm doing this on stylus and pen, so I can sort of rub it out. But if you're doing this with pen, you might have to like redraw the whole thing, which is a bit annoying, but it should be fine. Yeah, so you can just after you know P, everything kind of falls into place, and you can just start subbing in values, and you will find that the probability that neither happens is 1 on 72. So period and amplitude of wave 2. So this graph, you tell the period's just pi. Amplitude's just 5. So write W2 as a cosine function. So W2 is 5 sine 2t plus pi on t plus 6. So with these questions, as long as you can find pi on 4 somewhere, then you know you've done the right thing. So if you take out the dilation factor and you find a pi on 4, or a multiple of it, that means you can write it as a cos function. So since sine is, so if it's like adding pi on 4, then it's going to be in second quadrant. So since sine is positive, you would leave it as a positive. So, but you would change it to cos, and you would take out the translation. So it would just be 2t plus 6. If you're ever unsure, you can just chuck this into your CAS and chuck the original function into your CAS and just test some values, make sure you have the right thing. So is just W1 plus W2. So it's just 6 cos t plus 8 plus 5 cos 2t plus 6. And you can just add them together. There's nothing really you can simplify except for the constants. So period and range. So since the inner part of both the functions is different, the period, you're going to have to graph it to see what it is. But generally, it's going to be the bigger one. Because if you think about it, like the bigger one would be the constant one. So the smaller one would like act in blocks, I guess. But yeah, if you graph it, you can easily see it's the bigger one. And the range, again, you would have to graph it. And be careful of the domain, but in this question, there isn't really a domain. Other than that, t is time. So we can kind of assume t is greater than 0. But yeah, so for this question, it's just 8.1 to 25. So the graph of WR has local maximum here. Write down the smallest values of A. So again, if you graph it, you can see what A is. A is pi and 3 pi. And again, here it's important to note that A is a t value. It's also time, so it has to be greater than 0. Otherwise, you might get the answer of negative pi or something like that, but it can't happen because t is greater than 0. So label both graphs and sketch the graph of WR on top of the functions. So first thing you have to do is label which graph is which. So the one that has a higher, like middle value would be W1. So this is W1, this is W2, or you could test the initial values as well, either way. And then for the resultant function, easiest way to do this would be to find the turning points first, and the starting points and endpoints before you fill in the rest of the graph. So if you start with the endpoints, it's these ones, 4 pi and 25. Yeah, this is the range for which you want to draw it. So that's how you find the endpoints. And also there's a turning point at pi 13. It's a local maximum. And same thing at 3 pi 13. And there's also minimums, but the minimums don't have nice coordinates. And the graph doesn't ask for the local minimums. It only asks for the local maximum. But the values are like here-ish. So this one's down here, here. Oh, sorry, I forgot a maximum here. It's 2 pi 25. Here and approximately here. Just make sure they're all like, just look at the curves. And just fill in the graph. Looks like this. Oh, sorry. No. It's pretty ugly, but write it neater when you do it. Yep. So write down the coordinates of the minimum turning points. So that would be the ones that it's kind of hard to find just by looking at it because it's not like an exact value. But you can just solve on your CAS for Fmin. There's 4 of them. So I got -210 inverse square root 9113 plus 3 pi 8.1. The 8.1 is the same for all of them. The answer sheet has like this in terms of sign, but if you actually if you put this value and the x value that they give in terms of sign, it turns out to be the same decimal. So even if you wrote it in terms of 10, you still have the right answer. And the last one is 210 inverse square root 9113 plus pi 8.1. Like for example, I'm pretty sure the answers wrote this one as 3 pi on 2 minus sine inverse 3 on 10, but it's the same value. So when is the height of the wave changing the fastest? So again, for this one, just graph the one of resultant derivative and just find the minimum and maximum of that one. And that should be when t is 5.4, 11.7. These are the maximums. So like when it's changing the fastest in a positive way. And the other one is negative, 0.9 and 7.2. And that's when it's changing most in a negative way. So for what percentage of time is a wave greater than 20 meters? So for this one, you would just solve WT is 20. So you find the times when that happens. I got 5.62, 6.9417, 11.907, and 0.0585. Oh, I think that's not sure what that says, but yeah. So just find times when it is. And then by looking at the graph, you can tell like it's going to be this time and those times. So you find the the difference in time by just minusing the values you got. And then it's asking for the percentage. So percent time would be 0. This one was 685. So 0. You could just like add and add all the time differences, divide by the total time, multiply by 100, and you get 20.96. So last question is probably the hardest question of the paper, but yeah, just graphing stuff really helps in this question. So the first part is, for what value of A will there only be one solution? So for this question, you have a cubic graph of G, and kind of looks like this. So this is 2 and 3, and it's a negative 1. And you have a cubic function that's like this. So if there's only going to be one solution, then you can tell the graph of the cubic has to look like this, where this is the only solution. If it goes like this or something, there's always going to be a second solution up here. And since the cubic graph is like infinitely upwards, no matter how many like times you bring the cubic this way, there's always going to be a second one. And if you bring it forward, then there's not going to be any solutions. So for this value of A, that's the only time it's going to be, it's going to have one solution. But to figure that out, we have to do two things. We don't, we have to do two things. So the first thing we have to do is realize that at that point, they're like the cubic's going to be tangent with the square root function. So we have one is that f dash x equals f g dash x, but the other thing is also that fx equals gx, and we're trying to find A. So the reason we need two equations, say, is because we have two unknowns. We don't know when, we don't know the x value at which they're the same, and we also don't know A. So just do simultaneous equations in your CAS and solve for A, and you should get 2.542. So if A is less than 0, find the domain of the inverse of fx. So if A is less than 0, then the cubic is now looking like this. So the domain of the inverse would be the range of fx. So the range of fx would be negative infinity to 0. So domain negative infinity to 0. And we also have to find the rule. So to do that, you would swap, you would swap x and y. So x on A squared, 3 minus equals y. So y equals 3 minus x squared on A squared. That's your f inverse x. So find the coordinates of the point of intersection between f and f inverse x. So we know to do that, we never actually equate the two things. We always equate one of them to x. I chose to use the square root function, so I said let that's an x. A square root 3 minus x, so x squared equals a squared 3 minus x squared equals 3a squared minus a squared x. So you can, as soon as you see that the maximum order is 2, you can automatically try and use the quadratic formula. So points of intersection would be x is negative b squared, so it's a squared plus minus square root b squared, so it's a squared again, minus 4ac on 2, so x is negative a plus minus square root a to the 4 plus 12a squared, but you can see that you can take a squared out, so it's negative a plus or minus a squared, a plus a squared to 2. But the problem here is that it's only asking for a point of intersection. So you're going to have to choose between the plus or minus. And like the trick here is you have to notice two things. One of them is that A is less than 0 here. And the other thing is that since A is less than 0, the cubic graph, the square root graph is going to look like this. So the inverse is going to look like this. So the point where they intersect is going to be when x is less than 0. So if x is less than 0 and a is also less than 0, that to get a negative numerator, this thing has to be negative. But because a is already negative, to get that to be negative, you're going to have to use the positive. I hope that made sense. But yeah. So just keeping in mind that you need x to be positive and a is already positive. Negative. No. Sorry. You need x to be negative and a is already negative. So it's fine to leave it as the negative. So find the smallest value of a for which there are 3 points of intersection for f and the inverse function. So you might think, let me just draw it. So this time they've changed it. So a is greater than 0. So you have fx here, it's 3. And you have f inverse x, which is like here. That's also 3. So you might think it's like impossible or something to get 3 points of intersection, because you can see like if you like move it around, you'll only get 1. But actually there's a couple of ways you can get 3 points of intersection. So if I can draw this correctly, so to get 3 points of intersection, you actually have to make each graph go through the starting point of the other graph. It's kind of hard to draw. Let me see if I can try. Something like this. So you have one intersection here, and you have the other intersections at the points where they like start, I guess. So you have 3 things that you know. So one of them is that you can sub in. So wait, let me label the graphs properly. So this, maybe I should do them in a different color. So this is fx and this is f inverse x. So we know that fx has to go through the point fx is a square root 3 minus x. So we know it has to go through the point 0, 3 for this to happen. So 3 is a 3 minus 0. So we have our first a value is a square root 3. And you don't really have to solve for the other one because you get the same thing, but I'll just do it anyway. So the other one, so the first thing we know that fx has to go through 0, 3, and f inverse x has to go through 3, 0. So a squared equals y sub, so this is f inverse. So this one has to go through 3, 0. 3 minus 9 on a squared equals 0. So 3 equals 9 on a squared. So a equals plus or minus. Wait. So 3. So then a equals plus or minus root 3. But as a is greater than 0, so therefore a is root 3. So you get the same answer. So for a is greater than 0, find the values of a for which there are 3 points of intersection. And 3 points of intersection for f and the inverse function. So it's kind of the same thing as this graph, except they're like admitting, it's probably not a great word, but like they're including the fact that they can be like slight dilations with like these bumps. So like if you move them a bit, they'll be the same. But so the thing we have to avoid there is that they don't like intersect in the middle here. So they I'll show you what I mean. So So we have fx, so we have f inverse x, oh no, yeah, that's f inverse x, 3 meeting points. What was I saying? So, yeah, I graphed it wrong. so f, this is f inverse x. So, oh gosh, what am I doing? F inverse x, and so the thing we don't want happening is that, so before, like, we have this like area here, like that allows the middle point to be there, because otherwise then you'd only have 2 points of intersection. So if we're going to find a range of values, we have to find a range of a values that allow that middle point to exist. So what we don't want the graph to look like is, oh, I've done it again. So what we don't want the graph to look like is like, this is a bit hard to draw. Okay, well, it's not working. But basically, like, you don't want, we'll just try it again. So here, and this one's like here. So it's like, okay, I think I've extended the wrong parts of the graph. So just pretend this part and this part doesn't exist. But yeah, so like, you want them to still meet at the endpoints. But what we don't want happening is that there's no point in the middle. So that's what you have to stop happening. And that only happens when they're parallel at that middle point where they would have intersected. So to stop that, we find when what a value it is when that happens. So to do that, you do f dash of fx. So ddx of a square root 3 minus x. So that's a negative a 2, 3 minus x, and you would, it's one thing, and then you have ddx of your inverse function, so that's 3 minus x squared on a squared, so that's just negative 2x on a squared. So you would equate those two things in your CAS. Equate those two things. What else do you do? Oh yeah, sorry. And the other thing you have to do is also, so it's like it's kind of like this question actually. It's like you would apply the same concept as you did this question. So it's exactly the same things as these two. So you let f dash x and g dash x equal, and you also let fx and gx equal. This, my graph is kind of wrong, but like, yeah, sorry. It's just an example, like, yeah, sorry. So this is the simultaneous equation one. So let fx equal f inverse x, f inverse x dash x, that's the gradient, equal, and you solve for x and 0. You don't really, I mean, x and a, you don't really care about x, but you do care about a. A is 2. And again, you use simultaneous equations because you don't know the point at which it happens. So now you have your like limit, I guess, your upper limit. So when a is 2, that's when this point disappears. And when a is root 3, that's when that point appears. So since a is less than 2, the range of values for which there's more than 3 points of intersections would be when a is an element of, so 3, I mean, the root 3 is inclusive. because as we found in part D, that's the smallest value for which there's 3 points of intersection. But the 2 is not inclusive because once it's 2, that middle point disappears. So that's the question. I hope that made sense.